Hi, Bob.
Hello.
Hello. I presume you can hear me.
Yes, we do.
Very good. Okay, let me see. I want to share my screen, don't I? Let's see. Click on this little button, and I think I want to share that one. And the talk that I'm doing is Expecting Professionalism. So are you all ready? This is going to be a half an hour talk, everybody. So welcome.
Yes.
Okay, so I want to talk to you about a fundamental problem that we have in the software industry, and that is the problem of professionalism. And that will be the whole topic that I'm going to be talking about over the next 30 minutes. This is not a technical talk. This is a talk about our industry in general and what we're going to have to do to face the challenges going forward. And to begin with, I want you to imagine that I am your new CTO. I know this is not something you actually want. You don't want me to be an administrator because I'm actually a programmer and I'm not a very good administrator. But if I were your new CTO, I would have certain expectations of you. And you're going to hear these expectations. And if you've been a programmer for any number of years, you will hear these expectations in two different ways. One of your ears will be the ear of the programmer, and that ear is going to hear something unusual and strange and possibly even impossible. But the other ear will be the ear of the customer and the manager and the user, and that ear will hear something obvious and natural and perfectly expected. And it will be our function over the next few minutes to try and balance those two ears, to try and understand why what users expect is what we should deliver. This, of course, is what professionalism is. Professionalism is something we profess. And what is it that we programmers profess? Do we have a set of ethics? Have we written down some standards or some disciplines? Or do we simply say that we write a lot of code and we don't know what else we do? And more, it's the latter than the former. In order to be a professional, there must be something you profess, some set of standards and ethics and disciplines. And I'm going to be talking about those standards, ethics, and disciplines as expectations of the users. Why is this important? It's important because our civilization has found itself depending on software for its continued existence. That may sound like a statement that's somewhat exaggerated, but it's not exaggerated at all. There is virtually nothing you can do in the modern world without interacting with a software system. Everything around us is full of software. Our microwave ovens, our refrigerators, our telephones, our televisions, our automobiles, our airplanes, the computers around us. We get our news nowadays on computers. We do our reading nowadays on computers. We drive to the store with computers surrounding us. You cannot buy anything without interacting with a software system. You cannot sell anything without interacting with the software system. You can't call someone on the phone. You can't watch TV. You can't cook your dinner. You can't do anything in modern society without a software system being right in the middle of it all. And because of that, our society now depends upon software. And that, of course, means that our society, our civilization, depends upon us, programmers. You and I are the ones that our society depends upon. And we do not have a profession. We do not profess the kind of standards and ethics and disciplines that our civilization might expect from us. So let me begin to tell you what I expect. Number one, I expect that we will not ship bad code. I've got a word on the screen. Maybe you don't like that word, but it's an appropriate word. We will not ship bad code. We will not ship bad systems. We will not ship things that are unworthy of shipping. When we ship code, when we deliver code, it is going to be the best code that we can come up with. And I know there are schedules and I know there are demands, and still we are going to ship the very best code that we can with the best design and the best architecture that we can come up with, because our users expect no less of us, because our civilization expects no less of us. We must be diligent to make sure that we do the best job we can. There's a little secret that very few programmers know, which is that the only way to go fast is to go well. The only way to really meet your deadlines is to do the best job you can. Very often, programmers think that in order to meet a deadline, they have to cut corners. They have to be sloppy. They have to make a mess. But no, that's incorrect. Because every time you cut corners, every time you are sloppy, every time you make a mess, you slow yourself down and you slow everyone else on the team down. The mess slows everyone down. And you know this, and everyone knows this, because you, if you're a programmer for any length of time, have been slowed down by the bad code sitting on your screen. And it hasn't slowed you down a little bit. It's slowed you down a lot. So we want to produce the very best code we can, the very best design, the very best architecture, so that we can go fast. I expect that we will always be ready. Ready to what? Ready to deploy. I don't want to have developers tell me that it's going to be 3 months before we can deploy. I want developers to be ready to deploy every week. I presume that most of you out there are doing some kind of agile process. Maybe it's Scrum, maybe it's something else, but you are doing some kind of agile. Well, if you are doing agile, then you are following some kind of rhythm. And that rhythm is usually once a week, or maybe twice a week, or maybe once every 2 weeks, something like that. So you have a sprint or an iteration that you complete every week or every 2 weeks. I expect that the software you produce at the end of each one of those sprints will be ready to deploy. Now, that doesn't mean the business will want to deploy it. It may not have enough features for the business to deploy it. You may have finished the log out feature, but you may not have finished the log in feature, and the business might decide that they cannot deploy a system without a log in feature. But from a technical point of view, I expect that you will be ready to deploy. If the business says, we've got enough features to deploy, I expect that we will be ready to deploy. I don't want anybody waiting and saying, well, we should wait, 3 or 4 weeks. We should put it over here and burn it in for a while. We should put it on a special little test server over there and just run it and see if it fails. I don't want people doing that. I want you to be ready at the end of every sprint, at the end of every iteration. I want you ready to deploy if the business says deploy. I expect stable productivity. And by that I mean this. I don't expect you to slow down with time. People who are programmers who are on a greenfield project, who have just begun and there's no code, they can go very fast. But as the amount of code builds and gets larger and larger, those folks slow down. They get slower and slower because the code becomes more and more of a mess, and it takes them longer and longer to do anything. I don't expect that. I expect that you will go as fast today as you went a year ago when you had a greenfield project. I do not expect productivity to go down with time. I do not expect that you will create massive messes in the code that will slow everybody down for years and years to come. I expect your productivity to remain stable. I also expect inexpensive adaptability. Users are going to want to change the software. They're going to want to add features. They're going to want to change features. And they should be able to do this because you see, the word software is a compound word. It's made up of two words. The first word is soft. The second word is ware. The word ware means product. The word soft means flexible. Software means flexible product. The reason we invented software is so that we could easily change it. Had we not wanted to easily change our machines, we would not have invented software. So if you create a system that is hard to change, you have thwarted the reason that software exists. Software exists to be easy to change and inexpensive to change. One of the things that makes me very upset is when a software developer will come to me and say, these new features completely ruin our architecture. Well, if the new features ruin your architecture, it means that your architecture was pretty bad to begin with, because the purpose of an architecture is to allow change, to make change easy, to make it inexpensive. I expect that you can adapt to the user's changes inexpensively. Inexpensive adaptability, I expect. I expect continuous improvement. It seems to me that the software should get better with time, not worse, better. Many of us have experienced that software over time rots. It gets worse. It gets harder to deal with because it gets more and more tangled. The dependencies cross through it like a whole bunch of lines and nets. I don't expect this. I expect what anyone would expect, that the software will get better with time, that the code will get cleaner with time, that the design and the architecture will get better with time, that it will become easier and easier to add new features, not harder and harder. I expect ongoing, continuous improvement of everything. That's what human beings do. Human beings make things better with time. I do not expect our software to rot with time. I expect fearless competence. Fearless competence. Let me explain what I mean by that. Perhaps one day you were looking at your screen, and on the screen you saw some bad code. And you thought to yourself, oh, that's bad code. That's ugly. I should clean it. And your very next thought was, no, I'm not touching it. Because you know, if you touch it, you will break it. And if you break it, it becomes yours forever. And you don't want it to be yours forever. So you walk away. You don't clean it. You let it stay bad. This was a reaction of fear. You were afraid of the code. I want you to consider how wildly unprofessional that attitude is, how incredibly irresponsible that attitude is. You are so afraid of the existing code that you will not do the one thing that might improve it. You will not clean it. You will not make it better because you're afraid of it. Something has to be done about that fear, because if that fear persists, all systems must rot. All code must get worse. All designs must degrade, because no one will face their fear and clean the code. What can we do about that? How can we eliminate the fear? I want you to imagine that you have a magical button, and you can push that magical button anytime you want. And when you push that button, some lights blink and the computer makes some interesting noises for a minute, and then a little green light lights up. And if that green light lights up, it means that all the code works. The system works. If you had that button, you would not be afraid to change the code. When bad code appeared on your screen, you would say to yourself, oh my, I should clean that code. And your very next thought would be, I think I'll change the name of that variable. And you would push the button. Oh, green light. I didn't break anything. Good. That function there is a little large. I think I'll make it a bit smaller. I'll split it in half. Push the button. Oh, the light is green. I haven't broken anything. Good. That function I just split up, I think this half of it could move over into that class over there. Push the button. Ooh, it turned red. No, put it back. Push the button. Green. Good. Oh, I see what I did wrong. I should have put it in this class over here. Push the button. Green. If you had that button, you would not be afraid to change the code. You would not be afraid to clean the code. You would clean the code because cleaning the code would become trivial, something that you could do anytime you wanted if you had that button. So you must get that button. You must make that button. And that button, when you push it, must run a suite of tests. And that suite of tests must run quickly. The button must turn on the light within a minute or so. And when that light lights up, you trust that the system works. You need a suite of tests that will tell you that the system works. A suite of tests that runs fast and is easy for you to run. And it tells you that the system works. And if you have that suite of tests, you can be fearlessly competent. The fear will be gone and you will display competence because you will be able to keep the code constantly improving, always clean. There is a discipline that I want you to learn. This discipline is called test-driven development. I'm not going to describe it here. You can look it up. You can study it. That discipline will help you to create the suite of tests that you trust with your life so that you can be fearlessly competent. And that means that you will be able to do something else. I call this something else the Boy Scout principle. Because you see, the Boy Scouts once had a rule, and that rule was that you always left the campground cleaner than you found it. Now, I like to change that rule and say, we programmers always leave the code cleaner than we found it. We always check it in cleaner than we found it. We never check it in dirtier. We always check it in cleaner than we found it. When we check it out, we must do some change. Maybe we fix a bug, maybe we add a feature, and then we do some random act of kindness to make it a little cleaner. And then we check it back in. And if everybody did that, the code would get better and better and better with time. And that means that I expect extreme quality in the structure of the code, extreme quality in the structure of the design, extreme quality in the behavior of the system, in the way that the features run. I expect everyone who uses the system to nod their head and go, my goodness, this is a good system. I don't expect the users to wrinkle up their noses and go, oh my God, this system is terrible. Oh, gee, look at the way they misspelled words. You've got to click around 80 times to do anything you want. It crashes all the time. I don't expect that. I expect the users will look at your system and they will all go with wide eyes. My goodness, what a good system. I expect that we will not dump our bugs on QA. It is not QA's job to find our bugs. It is our job to find our bugs. QA should find nothing. When you submit your code to quality assurance, the QA people should find nothing. The QA people should wonder why they have a job, because they never find anything. In fact, I have a different role for QA. I want QA to be put at the beginning of the project. I want QA to be specifying how the system should work, specifying the tests that will prove that the system works. I do not want QA running the tests. And I especially do not want QA to be doing manual tests. I want all testing of the system to be automated. I want every test that is run to be an automated test, and I want it to run fast, and I want it to run surely. And if you think, well, that's not possible, I submit it to you as a design challenge. You are software designers. You can design a suite of tests that runs fast and covers everything. What you are looking at on this screen is a picture of a QA manager. See those hands there? Those are the hands of the QA manager. And he's holding out a document, and that document is the table of contents for his manual test plan. There are no tests in that document. Only the names of tests are in that document. It is only the table of contents. He has 80,000 manual tests that he must run once every 6 months. And the cost of running those manual tests is $1 million every 6 months. He's holding this document out to me because he's just gotten back from his boss's office. The year is 2008. The financial crisis has begun. His boss just told him that his budget is being cut by 50%. He's holding this out to me, asking me which half of these tests he should not run. And I told him, well, you can cut the document vertically or horizontally or chop it in half depth-wise. You're not going to know if half your system works. This is the ultimate fate of manual testing. If you test manually, you always lose the tests because the tests become more and more and more expensive to run. And eventually the accountants will simply say, you can't spend that much money on tests. It will happen every time. I expect the tests will be automated. You may react and say, oh, that would be so much work to automate all the tests. Oh, no. Running them manually is work. Automating them is what we do. We're programmers. We know how to automate things, and it would be much less work. I expect nothing fragile in the system. I don't expect that module that always breaks. I don't expect that function that's always messed up. I expect nothing fragile in the system. No weak link in the design. No weak link in the structure of the code. I expect nothing fragile. I also expect that you and I, programmers, will cover for each other. And by that I mean this. From time to time, a programmer will go on vacation, or perhaps get sick, or maybe even change jobs. I expect that other programmers on the team already know how to deal with the code that programmer was working on. I expect that if Bob is the database guy, and if Bob gets sick, then someone else like Jack or Jill or James can come in and work on the database without any delay. I expect that we can cover for each other. If one of us goes down, someone else can cover that hole. That's what a team does. Teams cover for each other because people sometimes go down. Now, how would you learn to cover for each other? Well, I recommend that in order to cover for each other, you work together a lot, perhaps even at the same workstation. Maybe you work in pairs from time to time so that you are sitting with one of your coworkers working on the same problem for an hour or two so that you understand what the problem is and you know where the source code is and how you can check it out and what the design of that part of the system is so that if your partner goes down, you can continue to work. I expect that we will be able to cover for each other. I expect honest estimates. I expect when you are asked for an estimate, you will give an honest estimate. And the most honest estimate you can give is, I don't know, because you don't know. You don't know how long it's going to take you to do something. On the other hand, I don't know is not a useful estimate. And I want you to produce useful estimates as well as honest estimates. So somehow you're going to have to take I don't know and put some kind of barrier around it. And this is the way I like to do it. When someone asks me how long it's going to take, I give them 3 numbers. I say, well, if everything goes perfectly, it'll take me a week. But if things go as they usually do, it'll take me 2 weeks. And if things go really badly, it could take me as long as 6 weeks. And then I wouldn't say anything more. And it'll be up to my boss and up to my managers to deal with that level of uncertainty, which, by the way, is their job. You see, managers have to do this thing called managing. And what they are managing is the uncertainty of all of the data that's out there, including all of the estimates. Now, of course, I would want you to improve your estimates every day. Every day, I would want you to go back to your boss and say, well, it looks like things are going pretty well. So I've changed those numbers. Now I think it's about a half a week and maybe a week and a half and maybe 3 weeks. Yeah. And then the next day you might come back and say, well, things have gone a little worse and I'm going to have to grow those estimates again. I want you to keep your boss aware of how those 3 numbers are changing. But I always want you presenting those 3 numbers because it would be a lie to give 1 number. You can probably be pretty honest if you give those 3 numbers. And I expect you to say no when the answer is no. You are the ones who know. So you are the ones who need to say no when the answer is no. Your boss doesn't know. They don't know how to make software. They don't know what's in the software. They don't know what it's going to take. You are the one who knows. So when they give you a deadline, they say it must be done by X. If it can't be done by X, you need to be able to say no. You need to be able to say, I'm sorry, sir, or ma'am, or whatever, but that's not possible. And you're the only one who can say it, right? You're the only one who can say, that's just not possible. You got to let them know. Otherwise, the whole business will run towards a deadline that it cannot meet. And promises will not be kept and commitments will be broken because you did not say no. Now, I don't want you to run off to your boss and go, no, 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 no. I want you to work very hard to figure out a way to say yes. But sometimes there is no yes. And you must not nod your head and say, well, okay, I'll do whatever. You must be able to say no when the answer is no. And be aware that sometimes you will be asked this question, and be careful of this question. You will be asked to try. Will you at least try? And your answer to that must be no. Because obviously you are already trying. It's almost insulting to be asked to try because you are already trying. You are already doing your best. So it makes no sense to be asked to try, and it makes no sense at all for you to say, yes, I'll try. Because when you say that, you are lying. You are lying because there's no change. You're not going to do anything different now because you said you would try. If you say, oh, yes, you're right, I will try. What you are really saying is that, I wasn't trying before. No, I was just being lazy before. Yeah, but now you're right, I should try. You must say no. We are already trying. We are doing the best we can. I'm sorry, but the thing you are asking cannot be done. I expect all those things. And with that, I shall bid you a fond farewell. I hope you enjoyed this very brief talk on expecting professionalism. Farewell, everyone. Enjoy your conference. And remember to be professional.
So very thanks, Bob. We have a few questions. So it's the first and I think it's the last question.
So the question seems to be, Uncle Bob, what software metrics and empirical methods do really help assisting software systems? There are so many metrics out there that are meaningless. There are a few that I have found useful over the years. But the most important thing is not the metrics. It is the act of keeping your code as clean as possible. Now, there are some metrics that can help you with that. Like one of those metrics is called Cyclomatic Complexity, which is really just a measure of the number of indents in a function. That you may find useful. Another metric that I have found useful is the number of lines of code per method. That number I want to be really, really small. I don't think functions should be longer than, 5, 6, 7 lines. I don't want them to be 20 lines or 30 lines or 40 lines. So I'd like to see a count of the number of lines per method as a measure of quality. I think that would be very, very, very useful. There are other metrics that are sometimes useful for measuring the way that dependencies cross inside of an application. And I will refer you to the books that I have written on that topic. I wrote a book recently called Clean Architecture, where I talk about that. I also wrote a book many years ago called Agile Software Development, in which I talk about those metrics. They're a little more complicated than I can deal with right now in this venue, but those metrics you may also find useful. Empirical methods, well, of the empirical methods that I think are out there that are the best are things like extreme programming and Scrum. Any of the agile methods are inherently empirical. They're all based on observational data. They're all based on lots and lots of feedback. I would be looking at Scrum, or better yet, extreme programming as an empirical method to help you run your software.
So we found all the questions.
So one more question. Let's see. How to grow as an engineering mindset. In software, one of the most important things you can do is read and study. This is not something that you learn in university. What you learn in university is the barest of beginnings, the basic stuff that might give you a help to get a job, but that's just the start. There is so much else to learn. So, for example, have you learned the design patterns? Do you have this book? Do you have the design patterns book? Have you read this book? Do you know the patterns in this book? Have you committed them to memory? Do you know Ivar Jakobsen's scheme for architecture? Have you read this book? Do you know what he's talking about when he talks about boundaries and interfaces and entities? Have you read the books that dominate our industry. There is 75 years of experience in software. All of it is relevant. The great mistake that young programmers make is that they think that everything is new and different now, and it's all that stuff that happened in the past is useless. That is utterly incorrect, right? All that stuff that happened in the past is immensely useful, and you must know it, and you must study it, and you must learn it. The future is based on the past, and you better understand what the past is. There's something really important you need to know as well. For the last 70 some odd years, we have been riding on a hardware wave. That hardware wave was growing at an incredible rate. It was called Moore's Law, right? And the speed of the speed of computers was doubling every 18 months. The space within a computer, the memory space, was doubling every 18 months. The space in our disks and the space on all our devices was doubling every 18 months. We were riding an exponential curve that took us from machines that had a cycle time of less than a megahertz to machines that now have a cycle time of 2.8 gigahertz. And that occurred over a very brief period of time, within my lifetime. Within my lifetime. I started working on a machine that looked like that. That little PDP-8 back there had a half microsecond cycle time. Here's one of the front panels sitting right there. That's from a real one. This was a fake one. That had 4K of core, 4K of memory. It had a half microsecond cycle time. We thought it was infinite. We thought we could do massive things with that. Now, of course, we look at, gigabytes as though they're throwaways and expect everything to be terabytes. And we want our clock rates to be way up in the gigahertz range. And we want multiple processors because we just can't seem to handle one processor in the gigahertz range. I want you to recognize that exponential curve stopped. It stopped in 2003. Since then, there have been very few hardware improvements. Clock rates have not gone up. Density has not increased. We've added a few more processors to our chips, but even that has stopped. And we are now on the plateau. The hardware has plateaued, and it's probably not going to increase very much over the next 5 or 6 decades. And I know quantum computing is coming. No, quantum computing is not coming, at least not in that sense. Because a quantum computer is an extremely limited device that cannot solve the general purpose problems that we have to solve. The hardware that we have today is pretty much going to be the hardware we're going to have for the next several decades. And that means that everything we have learned up to this point is going to remain relevant for many more decades. You want an engineering mindset? That's the challenge you've got to meet over the next several decades. The challenge of living on the hardware plateau. And with that, I must go. I have another appointment. Sorry, I cannot answer any more questions, but thank you all again for your attention. It's been a great joy for me to be here. Please enjoy your conference and adios, everybody. Must go.
Thank you. Bye.
Bye-bye.
Thank you for coming.
Thank you.